Heat engines and other cyclic devices usually involve a fluid and heat transfer while undergoing a cycle. This fluid is called the working fluid. The work-producing device that best fits into the definition of a heat engine is the steam power plant. The schematic of a basic steam power plant is shown in the illustration. The various quantities shown in this figure are as follows. Q in is the amount of heat supplied to steam in the boiler from a high temperature source, usually from a furnace. Q out equals amount of heat rejected from steam in a condenser to a low temperature sink. W out is equal to the amount of work delivered by steam as it expands in turbine. And finally, W in is the amount of work required to compress water to the boiler pressure. Notice that the directions of the heat and work interactions are indicated by the subscripts in and out. Therefore, all four of the described quantities are always positives. The net work output of this power plant is simply the difference between the total work output of the plant and the total work input. The heat engine can be considered as a closed system that undergoes a cycle, since no mass enters or leaves the combination of four major components, specifically boiler, turbine, condenser, and pump, as illustrated in the shaded area. Recall that for a closed system undergoing a cycle, the change in internal energy delta U equals 0. Therefore, the net work output of the system is also equal to the net heat transfer to the system, as demonstrated here. Based on the latest equation, Q out is never 0. Thus, the heat engine's net work output is always less than the heat input amount. That is, only part of the heat transferred to the heat engine is converted to work. Therefore, thermal efficiency represents a fraction of the heat input converted to net work output. This parameter is used to measure a heat engine's performance. For heat engines, the desired output is the net work output, and the required input is the amount of heat supplied to the working fluid. Then, the thermal efficiency of a heat engine can be expressed as in the following expression. The thermal efficiency can also be expressed in as the following equation, since W net out equals Q in minus Q out. Cyclic devices such as heat engines, refrigerators, or heat pumps operate between a high temperature medium or reservoir at temperature TH and a low temperature medium at temperature TL. To bring uniformity to the treatment of heat engines, refrigerators, and heat pumps, two quantities are defined, such as QH equals magnitude of heat transfer between the cyclic device and the high temperature medium at temperature TH, while QL is equal to the magnitude of heat transfer between the cyclic device and the low temperature medium at temperature TL. QL and QH are defined as magnitudes and therefore are positive quantities. Then, the net work output and thermal efficiency relations for any heat engine can also be expressed as follows. The thermal efficiency of a heat engine is always less than unity.